Hi everyone, it is the series of studying math every day, and it is another beautiful, and I want to do 2 sessions. There is something that I want to do always and always to wake up early. To wake up early became like one of the first things that I do, like one of the most complicated stuffs for me. So I just wanted to wake up like somewhere 5:30 just to start studying 6 p.m. And guess what? I just woke up like 8:30 and something, and right now it is 9:10. So I'm about to start my first session. So I only want to do 2 sessions because like I cannot do more than that. So yeah, I have to wake up early to make 3 sessions to make it 30 out of 30. So yeah, it will be. I hope it will be another beautiful day. So yeah, so let's start studying. Let's start studying my little kitty. And 10 minutes of break, it always resets. I don't know why they don't save anything in the browser, in the local storage. Yeah, so it's day 6, day 6, day 6. So let's go and let's log in.
Okay, so we got a special case now. When we first introduced linear equations, we talked about the three. Okay, so we got a special case now.
Is for. Now let's try one last example. 5 divided by x plus 2.
So I came across on this problem the last day that I studied. I think it was Thursday, 2 days ago, and it took me an hour just like to figure out how can I approach it. I kind of solved it, like I kind of solved the problem, but there was like some places that I was doing wrong, but like I was getting close. So today I wanna do it again. Although it's tedious and too long and it's gonna take some time, but still I'm not gonna jump off to the next lesson. So just wanna nail this one first. So that's what I'm gonna do. It's gonna take some time, and I would love to, solve it with you guys. Maybe just like what you guys see the way I'm solving it on this screen. But like I cannot do it because like I'm using a pen and paper. So maybe someday I'm gonna get some digital pen that I can use it. I don't know, they call it a name. So yeah. But before that, just watch me.
to factor in, so and negative 1. The expression remains the same. Negative 6x plus 1x is equivalent to. Notice you can factor by grouping.
Yeah, I tried my best, to be honest. And what am I doing wrong is the factoring. I think I'm using factoring by grouping, and I'm getting 4x plus 5 and x minus 3, to be honest. And 4x plus 5 and 4x, and I mean and x minus 3 do not have, like, right now I don't have any denominator and numerator that I can cancel out, so they're not even the same. So that's what I'm dealing with. So yeah, I'm just gonna move on. I think I'm gonna see like the way he's gonna solve it. This is where am I basically, okay? And then is that like 54 and 15? Is that what he said? I said it 5 and 12, I believe, right? Yeah. So 4 times 15 will give me 60. And even if I need to use the AC method, the AC method will give me, wow. I solved it. It will give me 4x plus 5 and x minus 3. So I don't know nothing about this one. He will choose what? Yeah, he also choose the same. But what am I doing wrong? That's what I want to know. Yes, I got the same in here. So that means I'm gonna leave it right here. So like that means there is nothing to cancel out, and you're just gonna leave it alone.
X plus 1 times x minus 1. So there's really nothing we can cancel.
Yeah, okay. Then I'm kind of right, I guess. Yeah, not guess, but like I'm already right. I was doing right here. I don't know if you guys can see. So I was asking myself, like, you should end up something that can cancel out. You should always end up. But like, if you don't have it, you're just gonna leave it as it is. You don't have to look for like a numerator and denominator that can cancel out. Don't need that. So you're just gonna leave it as it is. So yeah. Like one time I used the quadratic formula for factoring, and I was kinda getting what it's called, maybe a wrong value for x. So I already got x minus 3, and the other thing that I was getting was x plus 5. And so I think I'm doing something wrong there. Yeah, I'm kind of asking AI if this is what AI said. Oh, so I don't hear then the first case, so there is second case. So yeah, okay, multiply both sides by 4, and then that means it will be 4x plus 5. Nope, like this, to be honest. You need this. Yes. So the quadratic formula was also solving the problem. I wasn't understanding this, just okay. So the point is just like you're gonna multiply for the both sides. 0 times 4 will be just 0, and 4 times x will be 4x, and this 4 and also the 4 that's outside the bracket will also, like, they will cancel out. So yeah, kinda, you know, it's just math. There is some information that you're gonna forget, but like maybe solving more problems will make this information to stick in your brain and you won't forget them. And math is not all about memorization too. It is all about like solving problems, and then they will always stick around. You're not gonna forget them. That's how it is. So what else? I'm kind of feeling backache because like I don't do any exercise. But it is something that I have to change something about. I'm just gonna move on to the next lesson. But maybe, oops, I'm about to log in, but let's just say continue. There was something else that I was forgetting too. When you use the AC method, again, you need to use factoring by grouping. So you're gonna combine these two methods together. But like when using the quadratic formula, that's just like, that will give you straight away the true value of x. So do I take this quiz? So or should I just like move on? Let me factor in to find a common denominator. I think I can already studied this and I know it. First, let me check it. I'm not gonna spend a lot of time with this, but I got 9 minutes left in my first session, so I kinda wanna solve 1 or 2 questions. Simplify the expression by combining the 3 rational fractions into a single rational. So the first thing that I need is just to make the denominator the same. So how can I make it? They all share 2 of this share z. Okay. Gonna be a little bit tedious, I believe. Yeah, I cannot solve without writing stuff down. I have to. At least maybe I have to solve the first equation, or maybe this one. So it is x or y plus a yz square minus 4z4. So z yz x, then they both have z, but like it is z2 and z4. They all have 4. They all have. So it's missing basically z4. So what is missing? z4, and then 4 y z4 plus a. This one is missing z2 and also So the answer will be A, in my opinion. I'm gonna go with A. So yeah, I'm correct. Can I make this question under 3 minutes? Maybe. There is something, guys, tell me it is C. I can it's kind of simple, maybe, I don't know. But like the answer is C. That's what I think. I didn't write down anything. I just like calculated it in my mind. And there is something still me, and it is my mind that tell me it is C. Solution C. I don't know. Yes, it was kind of right. No way. Can I make it? Can I make this one too? Okay. The denominators are already the same. So yeah, you're just gonna multiply the numerators. So it will be 2b, I guess. And this will cancel out. Isn't it like that? These two should cancel out. This one got B and B. Is it just gonna be 1 on this? Because like B and P and minus P will cancel out. Minus TQ plus 2Q Q and also gonna cancel out. So that means it will be 1 or minus 1. What? So I don't know how it will be minus 1 though. They already canceled it out. Yes. So the equation got minus right here. So that means why it is A. I think it is A. Dude, no way. No way. I think it was kind of simple. I don't want to exaggerate myself. Exaggerate the thing. But yeah, I think that test was simple. I wasn't that smart. I'm dumbass, but like that test was so simple that a dumbass could do it even like in 10 minutes. So yeah, I got my first break and just wanna chill. So this is going to be my next session, and let's go back to studying. Basically, let's go back to studying. And also, there is something that's telling me I also studied this lesson. No, I did this one, I think. I didn't answer subtracting rational fractions. Yes. Factoring to find a common denominator. Yes, this one too. I know how to find a common denominator. So can I just like hop up into the quiz 79? Let me check. Yes, kinda. Maybe I'll need to read. I'll need to read the actual lesson. I think it's kind of easy, and yeah, I know how to do this. So let me just do it. Just do it. Just do it. My neck's aging. Oh my gosh. I woke up with this. It is not because of studying. Chill. Okay? I woke up with it. So I go up. FX plus 2. So I'm gonna try it, and then from now on, just gonna go in a mute. Where? No. Okay, so I'm gonna go with the D. I hope the D will be correct answer. It's the correct answer. Although I didn't use pen on paper, I think A is the correct answer. Cause like if I just reason, the two numbers will be x plus x plus 3 and x plus 7. So if we multiply x plus 7 into this, it will be 2x and also 14. So 14 minus 10 will be 4, and then 2x plus x will be 3x. So in the numerator we will have 3x plus 4. So this is what making me say it is A. I didn't write anything down, but yeah, it is what it is. Yeah, I'm kinda correct. Oh wow, I'm doing great today. I'm doing great today. I'm getting better, maybe, I don't know. Cause like consistency. Yeah, what about this one? This one looks a little bit tedious. Or am I thinking like that? Okay, it is 2. So what gives me just like 2 times 1? So both they're gonna be minus. So that means it will be minus 2 minus 1 will be just like positive 2. But this one will be, it will be, what it is called, minus 3t. Okay, so I'm gonna multiply both t minus 2, so it will be 2t and minus 4. So minus 4 and plus 4 will cancel out. 2t and t will be also 3t. So I have to get 3t. Then you, okay, this one is d2. Wow, my reasoning is just like, my reasoning is reasoning and my brain is braining and my thinking is thinking. That's what it is. So yeah, I can just move on, I think. Move on. Okay, multiplying rational functions. Have to read this one. Yes, it's just like, instead of adding and subtracting, we're gonna multiply this time. So it's kind of, I think multiplication is so simple when it comes to the polynomial. Dividing, I'll be back. Dividing, I will be back. Okay, let me deal with multiplication first, and just wait for me. Don't go anywhere. I will divide you into small pieces. So multiplying rational functions. in this lesson. I think what is this called when you have a polynomial in this format? And also it is a perfect, because like I don't know, they call it a name, but like I forget it. So you can just say a minus 4 and a plus 4. Maybe we can ask AI. Ah, sorry. Continue. Difference of squares. Yeah. So this type of polynomial is called difference of squares. Yeah, because you can just say a minus 4 and a plus 4. You have a square minus 4 square, and it is this type of pattern. Yeah, I always like to know the actual methodology of the thing that I'm studying. And also, you know, they always used to teach everything in my mother tongue, including math. So that's why I struggle with the right way of saying stuffs in English. Although I was still like dumbass in high school, but yet, you know, I'm just I still remember the terms, the methodology in my mother tongue. So yeah, this one and this one will cancel, I think, right? Yo, I'm kinda, maybe I'm about to watch and then come back to read it. Because like the book is focusing a lot more about, it is focusing a lot more about I don't know it. So yeah, let me just I don't even know what I wanted to say. I don't know, some selected rational expressions. Okay, I'm gonna say multiply rational expression. Dude, the organic chemistry is just so damn good.
Multiplying rational expressions and simplifying them as well. So here's the first example. In this video, we're going to focus on multiplying rational expressions and simplifying them as well. So here's the first example. 7x plus 14 divided by 2x squared minus 8. And let's multiply it by x squared plus 3x minus 10. Feel free to try this example. Now the first thing I will do is put the second part into a fraction, write it over 1. Now what you want to do is you want to factor completely and cancel. 7x plus 14 has a GCF of 7, so we want to take that out. 7x divided by 7 is x, 14 divided by 7 is 2. Now 2x squared minus 8, we can also take out the greatest common factor, which is 2. And that's going to leave behind x squared, and negative 8 divided by 2 is negative 4. On the right, we have a trinomial with a leading coefficient of 1. So we need to find two numbers that multiply to negative 10, but add to 3. So that's positive 5 and negative 2. So this is going to be x plus 5 and x minus 2. Now let's factor x squared minus 4. using the difference of perfect squares technique, we know it's going to be the square root of x squared is x, the square root of 4 is 2, and so it's going to be x plus 2 and x minus 2. Now let's see what we can cancel. So we can cancel an x plus 2, and we can cancel an x minus 2. So we have a 7 left over, an x plus 5, and a 2. So the final answer is, let's see if I can fit it in here, 7 times x plus 5 divided by 2. So that's the solution to this problem, fully simplified. Now let's try another example.
Just want to take a look at something. When we are talking about domain and range, is the range like the numerator and the domain is the denominator? Because we don't need the denominator to be 0, because like x cannot be 0, right? So yeah, I think the domain, when she's saying right here, when she's saying we need to remember that number is that excluded from the domain at least one of the rational exponents in the product, because they result in the denominator, at least one of the functions being 0 won't be in the domain of the product. So is the domain also the denominator? I don't know. Is the domain also the denominator? I don't know. How am I writing this? The domain of function where a variable is determined by excluding values that make that denominator equal to 0. So yeah, the domain of a function refers to the set of all the possible input values equal x that the function can accept without causing any mathematical error. So yeah, so the domain is the y always, and the domain is the x and the range is the y. So in this term, we need to remember that numbers that are excluded from the domain of at least one of the rational functions in the product, because they result in the denominator of at least one of the functions being 0 won't be in the denominator product. Can I just like, how I understood this, it's just like we should always we should always focus on the denominator, and we have to exclude like the thing is, or maybe a number that can make the denominator equal to 0. So that's not a function anymore, right? So I think that's how I understood. but I want to take it and ask it like DeepSeek. Break this down. Let's break down the statement piece by piece. Yeah, okay, got it. So that means x cannot be -1, because like if x becomes -1, it's gonna make the denominator 0, and if the denominator becomes 0, it will be just like undefined. So those the domain of the product, hell nah, not just, what the heck? It's because like this is a real number, I believe, because there was a guy that I watch. Have to pull up this, I think. Have to pull up this. This sign reminded me something, and I think they use it real number. I think it stands for real numbers. Where is it? What is Matt? Yeah, this dude.
So here's the process. Get rid of the +3. I'm gonna just like you. We added it in.
So, not manual, but like I'm gonna make it the newest.
Why?
Yeah. So R is imaginary. What the heck is this? Okay, makes sense. And that means makes sense. Makes sense. If an AI can introduce you to something new, what a world that we live in. Oh yeah, I got you, man. I got you. So if we factor and if we simplify the whole denominator, it won't be still obvious to know like the values that makes the denominator is equal to 0. So you need to tell it explicitly, just like you need to say x cannot be something like that. Okay, so x cannot be these values. So that's what you need to do, and that's what they are mentioning here. For example, in the product, x plus 2 and x minus 1 times x plus 1 divided by x plus 4, x minus 1 and x minus 1 will cancel out. The factor of x minus 1 will be cancelled. So the simplified version should be written as x plus 2 and x plus 4, and x cannot be equal to 1. Okay, here we consider a factor of x minus 1. Since there is no factor x minus 1 in the denominator of the simplified form of the product, it is an obvious from the simplified form that the value of x, which makes x minus 1 equal to 0, is x equal to 1. So it is an obvious from the simplified form that the value of x, which makes x minus 1 equal to 0, which is like the value will x is equal to 1, isn't in the domain of the product. This is why you should explicitly state that x cannot be 1 when we give the simplified form of it. Okay, it will also help us with this kind of problems to remember other factoring formulas, like the formulas for the difference and sum of squares. Okay, but like there was something that I was missing. I thought we will always take out of the last simplified version, you know. So I thought like we in this case we need to say x cannot be minus 4, because like minus 4 will make the 0. But like the case is not that. The case is just like the original denominator. So yeah, so that's why they are saying it cannot be obvious to know like what makes the domain equal to 0. So yeah, it is interesting, to be honest. This isn't the way that I was thinking. Even I was just like focusing on this part, and I would say x cannot be minus 4, but it's not that case. Here we consider a factor of x minus 1. Since there is no factor x minus 1 in the denominator of the simplified form of the product, it isn't obvious from the simplified form that the value of x, which makes x minus 1 equal to 0, x is equal to 1, isn't in the domain of the product. This is why we should explicitly state x cannot be equal to 1 when we give the simplified form of it. Okay, so simplify the expression by combining the two rational functions into a single rational function. So okay, to simplify the product, we need to simplify this part. We have to factor the top and bottom of the first fraction, so we're gonna factor both. So this is oh my gosh, I literally forgot it. Okay, perfect. Oh my gosh, I forgot what they were calling this binomial difference of squares. Was it that? Oh my gosh, no way, dude. No way. What is this called? They call it what? Okay, difference of squares. Yeah. Maybe I can close difference of squares. So this will be difference of squares, and this one will be what? For a, and this will be should be 4a times 4a, I think. Yeah, 4a and 4a, yeah, minus 1 on. It looks good. And this one is just like, dude, I'm just keep forgetting. Yes, and this is a difference of a square. So yeah, anything that can cancel out. Okay, this and this will cancel out, so it will just like it will be 4 plus a plus 4 and 4a minus 1, I think, if I'm not mistaken. Okay, cancel the factor that appear in both the numerator and the denominator, which is like 4a minus 1. Okay, I also forget this and this one. This and this will cancel out also, so we will only have 4a plus 1 and a plus 4. Okay, so 4a minus 1 will cancel from the numerator of the first fraction and the denominator of the second fraction. A minus 4 will cancel from the denominator of the first fraction and the numerator of the second fraction. So we are left with only so we are left with only 4a plus 1 and a plus 4. We cancel a factor of a minus 1 and a factor a minus 4, and there is no factor of either of those two tables in the denominator of the simplified form of the product. Okay, therefore it isn't obvious from the simplified form that the values of a, which makes 4a minus 1 or a minus 4 equal to 0, are not in the domain of the product. So we should explicitly state the hidden values of a that are excluded from the domain. To determine those values of a, we solve each of the equations for a minus 1 is equal to 0 and a minus 4 is equal to 0. So we're just gonna say, okay, we first need to divide 4 will cancel the other way. Okay. So yeah, and 0. So how did he? And what was the other one? Okay, so and it cannot be 4 2. Okay, so we should write the product as 4a plus 1 and a plus 4. A cannot be equal to, cannot equal to, it cannot be equal to a 1 divided by 4 and also 4 and positive 4. So yeah, I kinda understood the whole thing, I believe. All I need is to try some problems, and I'm about to do it tomorrow, and I hope I will wake up early tomorrow just to do more problems and to study 3 sessions. I only did 2, which is not enough in my opinion, but yeah, here's what it is. So yeah, we got 3 minutes left, and I don't even know what to do in these 3 minutes. Maybe have to just go back on my notebook and maybe review something, some old lessons in the experiments. Function notation. There is a topic that I want to go back to, maybe one day, I don't know. Yeah, and it is disjunction and conjunction. It's just kind of like interesting. I understood the thing I worked on, like I worked some problems with this conjunction and disjunction thing, basically, and still I think I need to understand deeply. That's what I need. So just wanna go back to it and maybe solve another couple of problems, and also inequalities too. But like algebra 1 was so damn good, and I thought like algebra 2 will be so difficult. I don't know why algebra 2 is so easy. Like all of the problems that I'm dealing with right now are so easy. I don't know what they will cover like these other sections, but like all I'm working on now, like all of the problems and all of these topics are just like so simple, and they all like related to algebra 1. I think maybe I understood algebra 1 so good that algebra 2 don't even make sense to me. Everything is just like so simple to me. Huh? Maybe you guys see me like struggling with solving some problems, but the point is just basically I know the idea and I know like the way to solve it, but like I always miss a single sign, and that single sign makes the entire equation wrong. So I need to improve my attention when I'm working on this science. So yeah, but like algebra 2, I was literally so scared of algebra 2 because like I was thinking it's gonna be like it's gonna be like so difficult that I have to walk my ass off. But this look is so simple, to be honest. And yeah, I have to go all the way, you know. So yeah, maybe one day I won't call myself dumbass, but instead I will call myself a mathematician. You know, I have an uncle who's so good at math, and you know, all he's doing in his life is just math. And yeah, math is fun, to be honest. And this is so interesting. So yeah, so it was day 6 of studying math in every day, and it was a beautiful day, and I learned a lot of stuffs, you know. So yeah, hope I will reach tomorrow well-being and healthy, and I hope I will get the chance and the opportunity to show up another day. So yeah, see ya.